So today is Monday, March 9th, 2015. This is WSSP Algebra 2, 5th period. We are on page 294. We're going to go through the first three examples of section 6-2, which is solving quadratic equations by graphing. And this is just lost the vocabulary word for that. Okay, a warning that I might cough a lot because I got sick over the weekend. So here we go. So I apologize for any pauses of coughing. Alrighty. I am looking at how does a quadratic function model free falling? You do it with a parachute. Okay? There's a little box right below what you'll learn about this section. Okay. Has anybody ever jumped out of a plane in this room?
I don't think we're stupid.
Whatever, I want to go skydiving, and I'm not ashamed to admit it.
My daughter did it.
Oh, yeah? Were you
Jumped
scared?
out of a plane on her 18th birthday.
You must have been scared out of your mind, Kathy.
I was. I would never.
I want to. I think it'd be fun.
I'll be scared too.
I guess I got one ally in the room.
My friend did it. She broke her leg in 3 places. That was the first and last one who did it.
Oh, well, Chris has a terrible story to go with it.
That's too bad.
Yeah.
Jennifer was fine, and she takes after her dad because he bungee jumped too in Las Vegas.
Oh my
I would
God!
never.
Off the side of the stratosphere.
That's scary.
I've heard of it.
Oh, well, let's see how we can apply some math to it. As you speed to the top of a free fall ride, you are pressed against your seat. Oh yeah. Well, yeah. Have you ever done it in a carnival ride?
Mm-hmm.
I've been on that Superman that got shut down because lots of people died.
Wow.
To your seat so that you feel like you're being pushed downward. Yeah, I've been there. Or if you've been on the Gravitron. That's kind of different. Then, as you free fall, you will fall at the same rate as your seat. Well, I hope so. Without the force of your seat pressing on you, you feel, quote, weightless. The height above the ground, in feet, of object in free fall can be described by the quadratic function negative 16t squared plus, we call this h naught. In Braille, it's h with the subscript sign and a 0. So we call that h naught, or you can say h sub 0. Okay? Where t is the time in seconds, and the initial height is the h naught. So every initial thing is always h naught, and that'll be important for you folks who are doing sciencey stuff. All right, here we go.
Yes.
H naught, or I always say h naught, but it looks like h sub 0. Just habits from a long math career. Solve quadratic equations. Here we go. When a quadratic function is set equal to a value, the result is a quadratic equation. Well, okay. A quadratic equation in bold letters can be written in the form ax squared plus bx plus c equals 0. So before we had quadratic functions, these are quadratic equations because they're set equal to something. Where a does not equal 0, and again, we can't let a be 0 because then we wouldn't have a quadratic term anymore. We'd have a linear line. We don't want no linear lines. That's algebra 1. All right. The solution of a quadratic equation are called the roots of an equation. So oftentimes I will say one or the other. I'll say roots or I'll say solution, and it's the same thing. That's just also a product of my long math career. So if I say roots, That means the solution, and vice versa. One method for finding the roots of a quadratic equation is to find the zeros of the related quadratic function. Again, a third way of saying it, okay? Now we have zeros, roots, and solutions. All mean the same thing. The zeros of the function are the x-intercepts of the graph. Why would that be? What happens when we're looking for the x-intercepts of something? What happens when we're looking for the x-intercepts? What do we do? In Algebra 1, what do we do?
Oh, they're gonna be over to A.
Nope, that's the axis of symmetry. I just mean in general, if we wanted to find the x-intercept of x equals 2,
Plug in Y.
y equals what?
0.
Right. That's why these are called the zeros. Because the x-intercepts are when y is 0. Or in this case, f of x. Okay? That's all they're saying. That's why they call them zeros. Important. All this stuff right here. This big old paragraph has a lot of information. Okay? The zeros of a function are the x-intercepts of the graph. I rewrite it again. These are the solutions of the related equation because f of x equals 0 at those points. So it just repeated what I just told you. Okay. The zeros of the function graphed on the right. Okay, where does it cross the x-axis in the picture on the right / in thermoform, I imagine? When y is 0, what are your x-intercepts? Why do you never answer my questions in this room? Not talking to you, Stormy.
I know, I'm trying to find it.
Why do you two never answer my questions when I ask you a question? I really want to know the answer to this. I'm not mad. I just want to know. Huh?
Trying to find the
Why? Why not? Like, is it what enables you to not answer my questions when I ask a question? Because it makes a big pause in the lesson, and it makes it seem like you're not paying attention. Okay? So, will somebody please answer what the x-intercepts are? No.
I'm trying to find it.
Yeah. X-intercepts. You just. When does the parabola touch the x-axis? On the picture on the right.
Oh.
Yeah, 1 and 3. Did you find the picture, Stormy?
Oh, it's again.
Yeah, I found it. I'm just trying to.
Yeah.
Oh, there's no. Oh.
So Josiah rightly said the second time that he was looking at the example, which we're going to talk about later. Is that the parabola touches the x-axis at 1 and 3 because y is 0. So you've got the point 1, 0 and 3, 0. Okay? Those are the solution, comma, zeros, comma, roots of that particular parabola. Okay?
Mm-hmm.
All right, we're going to find it again. And Josiah already said the answer, so I hope you weren't listening. 2 real solutions. Example 1. Solve x squared plus 6x plus 8 equals 0. What is A? Before we even start solving. 1. What's B? 6. And what's C? Stormy. Okay.
8.
All right, 8. And that all equals 0. So just as a caveat, always set up your quadratic equations equal to 0. If it doesn't say equals 0, you're going to have to do some housekeeping. Okay? It is very important. So let's graph the quadratic function, and then it lists it for you again. The equation of the axis of symmetry is dot 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 question mark. Right! Negative b over 2a. Okay, so that's negative 6 over 2 times 1, which is negative 6 over 2, which is
Negative 3.
alright. So again, we find that first because we know that's the center point of our parabola, and we want to choose points to the left and to the right of that. Okay? So they made a table for you, and they just went from the x value is negative 5 all the way to negative 1. Okay? So wherever y is 0 in this table, you know you have an x-intercept / 0 / solution. Okay? And if you don't like looking at numbers, you can look at the picture once you graph it. Okay? So, for instance, the x-intercepts are at negative 4 and negative 2 because in the table the y values are 0. Or, if you look at the picture, the parabola touches the x-axis at negative 4 and negative 2, so you can count. They didn't label this one, but I mean, if that all else fails, you can count squares, right? So does that make sense? Those are two real solutions. They touch the x-axis in 2 places, right?
Yep.
Of course, we can check by plugging in negative 2 for x and negative 4 for x. 0 equals 0 for negative 4, check. And 0 equals 0 for negative 2, check. Okay. So that's just your standard algebra rule of thumb. You should always check your answers before you know. All right. Any questions about that part?
No.
All right. The graph of the related function in example 1 has 2 zeros. Therefore, the quadratic equation had 2 real solutions. This is one of 3 possible options or outcomes when solving a quadratic function, equation, whatever. Same word. So let's look at the key concepts box, because we can have 1 real solution, 2 real solutions, or no real solutions. You guys have already seen some examples of this. What happens if your parabola doesn't touch the x-axis? Right.
No solution.
Right. And then what happens if your vertex touches the x-axis? Well, check it out. Look at the pictures. The first one gives you an example of 1 real solution. And since this vertex is the lowest point of the parabola, it's the lowest point, and therefore it only touches the x-axis once. So you say, oh, the vertex is the lowest point and it's touching the x-axis. Okay, it must be 1 real solution. Right? Because there's no, even though it kind of in the picture looks like the sides are touching it, you know, you just have to know that they don't. Because humans and computers aren't perfectly good at, you know, graphing perfectly. So the only thing that's touching is the x vertex section. And the next one, little picture, is 2 real solutions. We just saw an example of that. It's when the parabola touches 2 places on the x-axis. And so to the left and to the right of the y, it doesn't have to be. It could be on one side of the y-axis or the other, or it could be in the middle. Doesn't matter, as long as it's touching in 2 places. And last but not least, no real solutions where this parabola is floating off into space. It's still opening upward, but the lowest point is above the x-axis, so it will never ever touch it, ever. The arrows are pointing upward. So that's when we say there's no real solution, because it's not sitting on the x-axis whatsoever. Okay? Make sense? I hope.
Mm-hmm.
Alrighty. Well, let's try it with example 2. 1 real soul. I feel like I complained about coughing and I'm not coughing. Now I just jinxed myself. Alright, so 8x minus x squared equals 16. do we need to do some housekeeping? By graphing. Is this in the right order?
Yeah.
Yes on the housekeeping or what? Yeah, I think so. We gotta totally do some housekeeping, right? So we gotta move that 8x and move that 16 to the other side. We get negative x squared plus 8x minus 16 equals 0. You have to write equals 0 every time or it doesn't look like an equation. Okay. Then we gotta find our vertex. How do we do that again? I want to make you say it till it hurts your soul.
Negative b over 2a.
Alright, negative b over 2a. So that's negative 8 over 2 times negative 1. What's negative 8 over negative 2? 4. Exactly.
Yeah.
So they chose points to the left of 4, 2, 3, 4, 5, and 6. So again, I want to stress how important it is to always choose 2 points to the left of the vertex and 2 points to the right. And JJ made a good point, don't choose 30. I mean, you want to stay close to your vertex. Alright, well if you look at your y values, it sort of looks like your vertex is on a 0. Okay? So I have a sneaking suspicion that our solution is going to be 4, 0. And when you graph it, this parabola, if you look at the picture, opens down. Because remember, it only opens down if your a value is negative. Your x squared coefficient is negative. And as you can see, it's only sitting there touching the x-axis at 4. X equals 4. Okay? Then it opens downward and then continues its merry way into negative infinity. Alright? But of course we gotta check it. Oh, they're not gonna check it. Well, fine. Guess we don't have to check it. Alright, one last thing. That's right. I was gonna do the word problem tomorrow. No real solutions. You're just gonna graph today. Alright. This is we're gonna think about this. It's a number theory solution. And this is one of my favorite areas in math, is number theory. And it's writing equations like the following. I'm looking at example 3. Number theory. Find 2 real numbers whose sum is 6 and whose product is 10, or show that no such number exists. No numbers exist. Excuse me. Alright. Whose sum is 10 and whose product, or whose is 6. Alright, said that backwards. Yeah, whose sum is 6 and whose product is 10. Alright. Well, of course, let x be one of the numbers. Right? Then to figure out what number adds up to 6, you could say we don't, the only thing we know is that the sum of x and some other number equals 6. So they say 6 minus x equals the other number. Okay? Because we don't want to use 2 variables. Do parabolas have 2 variables? No. Right? So you want to find a way to set it up in such a way that you have one variable. So for instance, 6 minus x equals the other number is the same thing as saying one number plus the other number equals 6. It's just solving. Okay? So then, since the product of 2 numbers is 10, you also know that that number, x, times the 6 minus x, which is supposed to represent the other number, equals 10. So now we have a little equation. X times 6 minus x in paren equals 10. Well, then we distribute, right? 6 times x is 6x. X times negative x is negative x squared equals 10. Starting to look a little familiar, right? Have to do some housekeeping. Sure. Yes. Then we move the 10 over and switch everything into the right order, right? And get negative x squared plus 6x minus 10 equals 0. Don't forget your equals 0. When you move the 10 over, there's nothing, but you still got to write equals 0. All right. You can solve this by graphing, the usual routine. Okay? Here we go. What is vertex?
So,
Right. What is negative b over 2a? Negative 6 over,
over
right, which is negative 6 over negative 2. What's that? 3.
2, 3.
Right. Yep, negative 6 divided by negative 2 is positive 3. So they have a pretty table for us, and they choose 1, 2, 3, 4, 5. They just choose 2 points exactly to the left of 2, or 3, and 2 points exactly to the right of 3. But if you notice, look at your y values. They go negative 5, negative 2, negative 1, negative 2, negative 5. Where the heck is 0? Right? So where would, between which two values of x would 0 be for y? I don't know. Let's graph it. What happens? Is it anywhere near the x-axis?
You find your graph.
No. Let me ask you an Algebra 1 question. What quadrant is this parabola sitting in?
3.
Nope. 4, says Josiah.
Oh, 4.
Right. It's sitting in 4 and it's pointing downward. So will it ever cross the x-axis? Nope. So we say this thingy, this number theory one, has no solution. There is no such number that adds to be two numbers that adds to be 6 and multiply to be 10. You can always check. 1 plus 5 is 6, but 1 times 5 is 5. 4 plus 2 is 6, but 4 times 2 is 8, and so on. Okay. This would also work for non-real or for non-whole numbers. Like it could be like 2.5 plus hertz 3.5. Ew. And 2.5. You get it. It would find any of those numbers if such a number exists. Okay. So that's it for today. We're gonna do the rest of the section tomorrow. Your homework is on page 297. Actually, hold on. It's actually going to be on 200. Yeah, it's there. Never mind. 297. 297. I'd like you to do 13 to 21. Okay, 13, 21. The first one's a number theory problem. You can get it over with. Okay, and the last two are graphing, making a table and solving by graphing. Okay, and if you get done before the end of the period, I have plenty more for you to do.
13.
Hold on. Yeah, 13 through 21. All right, I'm gonna stop the recording.